Hi there, my name is Abby Germain and I'm going to explain stoichiometry for my video from chapter 12. Stoichiometry is the study of quantitative relationships between amounts of reactants used and products formed by a chemical reaction. We learned stoichiometry in chapter 12, but it was very important and we carried it over through several other units. To do stoichiometry, we need to know the balanced equation of a reaction. To balance an equation, you simply add coefficients to the components of the equation so that there is the same number of atoms on each side of the equation. However, in the problems I will be doing, they already give you the balanced equation, so it's not necessary to do this step. To do stoichiometry, we also need to know the number of moles of one of the substances to find the mass of another substance. Lastly, we need to know the molar mass of the substance we are given. Once we have all these parts, we can begin the problem. In a stoichiometry problem, you would first multiply the number of moles of the known substance by the mole ratio, which can be found by looking at the coefficients in your balanced equation. Then you would multiply this by the molar mass of that substance, which can be found by adding together the molar masses on the periodic table of all its components. Or I have a handy dandy molar mass app that I use and it saves a lot of time, but that's the official way to do it. So let me show you a couple examples of this. Number 11 on page 360 says titanium is a transition metal used in many alloys because it is extremely strong and lightweight. Titanium tetrachloride is extracted from titanium oxide using chlorine and carbon. If you begin with 1.25 moles of TiO2, what mass of Cl2 is needed? So, to do this, I would first write 25 moles on the top, and then I would multiply it by the mole ratio, which is 2 moles of Cl2 on the top and 1 mole of TiO2 on the bottom. And then I would multiply this by the molar mass of Cl2, and that is 70.9 grams on the top and 1 mole of Cl2 on the bottom. And I got I got 177 grams for my answer. So for the second problem, my second example, number 13 on page 362 states that one in a series of reactions that inflate airbags in automobiles is the decomposition of sodium azide. Determine the mass of N2 produced if 100 grams of NaN3 is decomposed. So I started out by writing 100 grams, and then from this I actually multiplied it by the molar mass first because we started off with the grams rather than the moles in this problem. So I multiplied it by 1 mole of NaN2 over 60 grams of NaN2. And then I multiplied it by the mole ratio, which is 3 moles over 2 moles. And then lastly, I multiplied this again by the molar mass, which is 28 grams over 1 mole of N2. And my answer for this, I got 70 grams. Thanks for watching.